We're going to be taking a look at 2011 number 3. And if you have not yet done that problem, then let me encourage you to look that up on AP Central, find it, and do that problem. We'll see you back when you're done. Welcome back. For 2011 number 3, we're given a region. And the slight wrinkle about this problem is that the region is defined in terms of a parameter k. And this curve is y is equal to e to the 2x, and this is k, and this is 1. And now we are asked to write but not evaluate an expression involving an integral that gives the perimeter of R in terms of k. And the only tricky thing about this is that we just have to make sure that we don't overlook anything. So let's walk through and just mark off segments as we do them. We'll do the hard part first. The hard part is going to be the length of this curve, which is going to be an arc length. And so the length of that curve is going to be constructed as the integral from 0 to k of ds, which is 1 plus f prime squared. And notice that f prime here is in terms of x, not in terms of k. So that's going to be equal to the integral from 0 to k of root 1 plus 2e to the 2x squared dx. And that takes care of the first segment. As we're constructing this, we need a nice good label for it. Let's call it the perimeter of R, PR, piece of R equals. Now we have to come through and add the other segments onto it. The length of this segment, which is vertical, can be found by subtraction. That would be e to the 2k minus 0. The length of this segment right here is going to be is horizontal. That's going to be found by subtraction. That would be k minus 0. And the length of this segment right here is going to be 1. So that your final expression is going to be that PR is equal to the integral found here plus e to the 2k plus k plus 1. Just like that. They scored this like so. Let me make sure I'm on the right. Nope. We need to be on the Calc BC page here. Well, that's exciting. Why won't that pull up? There we go. They scored this 1 point for simply finding f prime as 2e to the 2x, 1 point for setting up the integral to compute the segment above, and 1 point for the entire answer. So you have all of this right here as f prime. That's a good question. That's a really good question. What's the guiding principle here? My intuition is that if I have an expression involving f prime, I ought to say what f prime is. But often in calculator-based problems, we don't do that.
But then an equal sign means it's equal to x.
Yeah. That's a really good question, and maybe some of the student solution, the sample student solutions might shed some light on whether they accept that or not. My gut intuition is that if I have an expression for f prime on a non-calculator kind of a question, then I might as well put f prime in there. But I don't have hard and fast guidance from AP as to why they would require that. I'm pretty sure they would require that. But that's a really good point. I'll take a look at it and try to get some further guidance. Question back there? The region R is rotated around the axis, about the x-axis to form a solid. Find the volume V of the solid in terms of K. And so we are going to say that the volume is equal to pi times the integral of r squared dx. Notice that the inside radius is 0 because my curve is flush with the x-axis. My region is flush with the x-axis, or bordered by the x-axis. And I'm going to integrate that from first x to last x, which is k. So here, Lydia, would be a case where it's fairly obvious that I would need to substitute for r in this particular case, even if they didn't have me simplify it. And mercifully, e to the 2x quantity squared is simple to evaluate. And I get pi times 1/4 e to the 4x from 0 to k. And of course, we want to avoid the trap of falsely believing that e to the 0, 0. It's not, it's 1. And so your final expression is going to be this guy right here. The scoring for this was 4, actually. 1 point for having the right integrand here. 1 point for having the limits 0 to k. 1 point for having the correct antiderivative of e to the 4x. You're in a generous mood today. And 1 point for your final answer, which here they expressed in multiplied out form, but also you could have in factor form as I did.
I'm just curious, going back to Lydia's thing, if you like,
Yes.
if it was like find an expression for the volume of this, but don't solve it, and you just wrote, you know, like integral, and you just use f of x in there, would they care then? Because I mean, that's, instead of writing out, you know, I believe we've done that before.
I think that if the intent was to allow you to use f, they would say in terms of k and f.
I'm not saying for this, I'm just saying in general, like if they wanted an integrand or something,
Yes.
it's like usually like an area in between curves, for instance, and you just did integral from 2 to 1 to 2, or f of x minus g of x dx, just like this.
Yeah. Let's say I've got a calculator problem, okay? And let's say I've got two curves that intersect at 0 and 2. You can start in on another packet if you want.
Oh, I wanted to show you.
Oh. Okay, hang on, let me pause this. Okay, so say I've got F and G right here, and I need to find the area. I've got the intersection points. If I write this just as it is, and then I give a number for it right here, this is really the thing that they're after, right? And this is the process that leads me up to that point, and the communication is clear. If, on the other hand, I'm working on a non-calculator problem, or even a calculator problem, and they ask me for an expression that gives blah, 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 maybe the area, then this right here might very well come across as just a canned formula. And so I'm reasonably, this is undoubtedly wrong for that shape of curve, but you know. Then reasonably I would need to actually substitute here. To get that.
So it's fine for the non-calculator, but for the regular calculator, but
It's fine if you're moving on to give an answer here. I'm struggling to explain this because it's almost an intuitive thing.
right, naturally I would write it, but the whole thing now, I'm just saying, like,
Yeah,
If you were touched, short on time, like
short
you
of
were
time.
quick or something, then.
And again, let me encourage you not to stress over individual points too much, because your score will not be made or broken on a single point. We're trying to communicate clearly. If you're making good efforts to communicate clearly, it'll average out.
I think it's weird and common things require that because they don't even ask you to evaluate. If you're not even doing that,
Yeah.
then why do you need to find
And it may be as I delve into the sample student answers, that they will say, we accepted blah, blah, blah. Yeah. It's kind of weird. I'm trying with you guys to get across clear mathematical communication. If you're doing that, I'm not. Okay, so we found the volume of the solid in terms of K. Part C asks us to find dV/dt given that dK/dt is equal to 1/3. And we're supposed to find dV/dt when K is equal to 1/2. And the intent of this question is to make sure that you can skillfully negotiate your different variables, right? So, because I have already volume equals pi over 4 e to the 4k minus 1, now I need to express dV/dt using the chain rule. So this is going to be my first thing. And then I have to go through and actually compute these things. That's going to be pi over 4 times 4 e to the 4k times dK/dt, which is equal to 1/3. And when k is equal to 1/2, notice the notation that we use here. I can't really say of 1/2 because that would imply when t is 1/2, which is not the case. Since dV/dt is evaluated at k equals 1/2, is going to be equal to pi times e to the 4k divided by 3. And they scored it as 1 point for applying the chain rule and 1 point for the answer. And that was kind of it.
I don't know, were you doing this, do you know? Minus 1 and
Minus 1.
if you were doing, because we both, so we were both, we both doing like,
Oh, so you didn't evaluate here, and because you didn't evaluate here, you
no,
can
I
stick
think
it
we
right
yeah,
there.
I think it's right minus 1. We just wrote,
Well, here, there would be no minus 1, because we have the derivative here, and the derivative of a constant would be 0. Right? But here, we have the actual wrong expression for the volume, but then you compensate for it with the correct derivative. They probably will consider that a typo and not ding you, but it's a little strange because we didn't have the final evaluation there. Now that I'm certain of, we need the final evaluation.
yeah, no, what I did wrong here is I only did K and I forgot about that. Because like this is where I forgot how to count that.
I see. The
Yeah.
0 to k is added by the greater.
Yeah.
Got it. Okay. Yep. Yes. Got it. Yes, just remember that e to the 0 is not 0.
Well, I totally forgot, like, that was just.
Yeah.
Yeah.
Everybody's done that at least once in their lives.
There's just nothing that was.
My favorite is integrating negative sine x from 0 to something. That one I just insist on dorking up because you have so many minus negative, double negatives, triple negatives going on. Okay, any questions? Very good. All right. Well, that's it for this question.